So we've been looking at vectors and we've been calling them, naming them things like vector u, vector v, vector w, and denoting them like this. And we could use these generically and change the components of them for whatever we want. But there are two vectors that are very important that have been given specific names that we don't want to change. And those vectors are vector I and vector j. So the vector 1, 0 is given the special name vector I. So let's think about what that vector looks like. It's going to start at 0, 0, and it's going to go 1 in the x direction and 0 in the y direction. And this is vector I. If you see vector I anywhere, that's who vector I is. Similarly, vector j is the vector moving in the vertical direction, starting at 0, 0, coming up to 0, 1, and that is vector j. So this is vector I and vector j in standard position. Now remember, these are vectors, they can live anywhere, all right? So that's vector I, assuming it's magnitude 1, all right? All these are vector I. All these, assuming this is magnitude 1 and headed vertically straight up, are vector j. The vector negative j, the vector, oops, that's a y. The vector negative j, can you picture what that would look like? Negative j, right? That would go down, right? Negative 1, 0, that'd be negative j. And of course, then the vector negative I, or the opposite of I, would be heading to the left 1 unit. All right, so why these vectors are important is we can actually use them to name vectors as an alternative notation to this form, which is called component form AB. We can notate it this way. Now, I think on your paper, these are not bold, these I and J, and they should be because they represent vectors. So what I want you to do is put a little vector symbol above the I and above the J if those are not bold. All right, so for example, let's say I want to compute 5 times the vector I, which is 1, 0, plus negative 12 times the vector j, which is 0, 1. All right, so using the same techniques we did before, we can multiply the 5 into the parentheses, multiply the negative 12 into the parentheses, and then simply add the x components and add the y components. And what do we get? We get the vector 5, negative 12. All right, so the vector 5i plus negative 12j has components 5, negative 12. It's just another notation that we can use. If we have a units in the x direction, we're going to multiply that number by the vector I. If we have b units in the y direction, we're going to multiply that by the vector b, or vector j. All right, so let's write the vector negative 26.5 pi as the sum of I and j. How would you do that? So basically what I'm doing here is I'm giving the vector to you in component form. All right, I'm giving it to you in this form, and I want you to write it in this form as a sum of I and j. Can you do it? All right, hopefully you wrote negative 26.5 times vector I plus pi times vector j. And we don't put brackets around it, right? Why don't I put brackets around it? I don't put those brackets because the brackets are in the vector I, right? The brackets are in with the vector I already. You don't go like this. If I have vector u, I don't go like this. That's redundant. Okay? You only use these little bracket arrow thingies when you have the components of the vector, not the actual vector symbol. So speaking of components, let's say I have the vector AB. I could visualize that as, let's draw this vector. Let's say this is vector V. and it has components A, B, well, I could visualize that as a right triangle with this side length being A and this side length being B. So we call A the horizontal component of the vector. It's telling us how much the vector is moving things in a horizontal direction, that particular value. And we call the B value, you guessed it, the vertical component. That value tells us how far the vector is moving something in a vertical direction. So let's say that we have vector V, and it has magnitude 5 and a direction of 120 degrees. Now, when we talk about direction, we're going to talk about, just like we've been talking about, an angle in standard position. So I'm going to draw an angle in standard position that's 120 degrees. So it's going to be about right there. All right, 120. I'm going to use a different color for that. Let's use orange. So this has a direction of 120 degrees, and it has a magnitude of 5. So basically the length of that vector is 5. And we want to express V in terms of unit vectors I and J. So we want to write V equals something times I plus something times J. So just like in this picture up here, the something I is going to be the horizontal component. I'm going to write this up here so we can visualize again like a right triangle. Maybe I'll draw it dotted and dotted over here. And so this is going to be my A value, and this is going to be my B value, my horizontal component and my vertical component. See anything that might help us there? Does this look familiar in any way, shape, or form? I mean, all of this is connected. And literally, you could think of this as a polar coordinate, really. You could think of this location on the plane as the polar coordinate r theta. And what you're trying to do is convert that to Cartesian coordinates. And then you're going to use those Cartesian coordinates to write your vector. All right, so how are we going to find A and B? Well, we could use right triangle trigonometry, right? We could also use our polar conversions. We know that A is going to be equal to r cosine theta. I'm using A just because that's how I have it labeled in the picture. It's the x component, right? And B is r sine theta. And we know 120 degrees, so let's just do it exact. So my radius is 5. 5, oops, not sine. Let's try cosine. 5 times the cosine of 120. What's the cosine of 120? That picture kind of helps, doesn't it? Negative half. All right, so that's negative 2.5 or negative 5 halves. B is 5 times the sine of 120. So that's 5 times square root 3 over 2. All right, so our vector V in terms of I and J is negative 2.5 vector I plus 5 square root 3 over 2 vector J. Now this problem asked you to write it in terms of vectors I and J. But just for fun, if we wanted to write this in component form, it would look like 2.5, 5 square root 3 over 2. 2.5 is kind of bugging me because I got a fraction and a decimal. It doesn't matter. It's probably a little bit. But doesn't this look a little bit better since I have a fraction with the other one? Now, this is a vector. I don't want you to have any issues with that. But if I did think of this point in the xy plane, the coordinates of this point would be parenthesis negative 5 halves 5 square root 3 over 2. The vector negative 5 halves 5 square root 3 over 2 has an initial point of 0, 0, and a terminal point of these coordinates when it's in standard position. But remember, this vector could be moved anywhere and still be the same vector.